Good evening, ma'am.
Good evening, everyone. Am I audible?
Good evening, ma'am. Yes.
Yes, ma'am. Good evening, ma'am.
Yes, ma'am.
Yeah.
Yep.
Good evening, ma'am.
So the screen is also visible, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, good. Okay, so today we will see the summary of week 2. So in week 2, so here are the main topics from week 2. So first we see, mainly here we are doing everything for categorical variable. So can someone,
Excuse me, ma'am.
yes?
And before starting, can you explain in little bit in detail because I have not studied week 2.
Yeah, we are
You
going
don't
to see
mind?
all the topics in detail only.
Okay, thank you, ma'am.
Yeah. So we are going to mainly concentrate on categorical variables. Okay. So can someone tell what are categorical variables or categorical data? What does it mean?
It's the qualitative data.
Qualitative data.
It's qualitative, right?
Yeah.
Okay. So here we are going to see how to study more about this kind of categorical data. Okay, so to understand that, we first are going to see how to create what are called frequency and relative frequency tables. Okay, so these tables are the very first step to understand any categorical data. Once we have the relative frequency or frequency table, then we can also form what are called this graphical representations, which are pie chart, bar chart, and Pareto charts. Okay, and to make a well presented chart without any errors, there are some specific practices, and to see how to avoid errors, we have some certain principles also, that also we will be seeing. And at last, so how to see, these are like graphical or just visual representation of the given data. But if we want some descriptive measures in terms of some numerical measures, or not specifically numerical measures, maybe descriptive measure is the correct way we can say. So in that case, we can see what is mode and median of the given set of categorical data. Okay, so these are the things we are going to see today. Okay, so we will quickly recall what are categorical data. So let's see how far you can remember categorical data. So here is a quick question. Can you all read this and give me an answer? What kind of variables or comparative forms
Categorical, ma'am.
Yes.
It's categorical.
variables.
So here you can see that
Yes, ma'am.
you have more, less, good, better, and best. So this is actually categorical variable. In categorical variable, are there subtypes?
Ordinal.
Yes, ma'am.
Yes,
ma'am.
ma'am. Ordinal,
Ma'am,
ordinal, nominal.
Yeah. So what, under which category does this particular example belong to?
Ordinal.
Ordinal scale.
Ordinal
You can order, right? It's having a certain order, right? Okay, fine. All right. And what about the next exercise? So what kind of variable is the qualification of a candidate sitting for a job interview? So let us say he has a BTech or,
Qualitative.
yeah, so whatever it is.
Categorical and
Qualitative.
qualitative.
Categorical, qualitative. Categorical.
So you see that. So here also it's categorical, and here also it's categorical.
Qualitative.
Yeah.
Yes,
Okay.
ma'am.
Ma'am, can you explain exercise, ma'am, this second one question?
Yeah, so here we are looking at, suppose what are these, let us say there are 5 candidates appearing for an interview, and the qualifications are listed as follows. So someone is having a BS degree in data science. Okay, someone is having a BTech degree from computer science, and someone is having a BE degree from mechanical. So these kind of qualifications are given. Okay. So now how do you classify this? Whether this is categorical or it is numerical? Obviously categorical, right? Yeah?
Yes. Yes,
Yeah.
ma'am.
Yes.
Yes, ma'am.
Okay, fine. Okay, so now moving forward to the topics from week 2. So first we'll understand what are frequency distributions. Okay, so a frequency distribution of a qualitative data is a listing of the distinct values and their frequency counts. Okay, we don't list whatever is given in the data. We just list only the distinct values. Okay, and for each distinct value, what are the count? Okay, so just by looking at this statement, this might not be clear, but when we do examples, this is going to be very easy. Okay, so maybe straight away I will go to the examples and then we'll come back here. Okay, so here, look at this example. The following data represent the shoe sizes purchased at a shoe store on a particular day. Okay, so these are the shoe sizes. Okay, first of all, can you all just look at this data and tell me how many distinct values are there and what are they?
5, 6, 7, 8,
5, 6, 7, 8, 9.
9.
So how many are there?
5.
10.
5.
5.
Okay. So whatever these unique
Yes, ma'am.
values are there, that we are going to first list them. Okay, we are going to
5, 6,
first
7.
list them. Okay. After we are listed, we are going to count each of this entry present here. So first of all, 5, how many times is it appearing?
2.
So
Two.
it is
2.
here
5 times.
and then here. So we
times.
are putting 2 lines representing these 2, 5. Okay. And then how many times 7 is appearing?
6.
4.
6 is 3 times,
One,
ma'am. 6
4.
is 3 times.
4 times.
4. So it is appearing 4 times. All right. Okay. And 8 is appearing
6 times.
1,
6 times.
2, 3, 4, 5, and 6. So
6
8 is
times.
appearing 6 times. So whenever for tally, you see after 4, you should mark it like this. So this is 5 and then 6. This is the usual procedure to make tally mark. Okay. For example,
Yeah.
suppose you have to represent maybe 11 in tally mark. How do you represent 11 in tally?
5, 5, 1.
So you
5,
represent
5,
like
1.
this
Yeah.
and then 1. Right. So just for those who are not familiar, this is how we represent tally marks. All right. What's the next number? So here you have 9. So you have 9 appearing once,
4
2,
times.
4 times.
4.
4 times.
Yeah. So this is
4
also
times.
appearing 4 times. And 6 is appearing 1,
4
2,
times.
3, 4. Okay.
4 times.
You are having 6 appearing 4 times. So 2, 4, 4, 6, and
6.
4.
6, 4.
Okay. Now here, can you count how many shoes were first of all purchased on that day? Count
Total
how many
20.
data is given here?
The total is
Frequency
20.
20 finally.
20.
20.
Total 20.
Okay. So you note that
Yes, ma'am.
so 20 entries are here. Okay. So this means, so you can see that when you calculate the sum of the frequencies, that same number should appear. Then only whatever you have counted is correct. So if you want to match the correct count, so you can verify whether the given number of data is matching with the sum of the frequency. What is the sum of the frequency here?
20.
20.
20.
Okay. So this represents the total number of data. Okay. So the sum of frequency represents the total number of data. Okay. So now let's go back
Yes,
here and see the same. A frequency distribution of a qualitative data is a listing of distinct values and their frequencies. Right. That's what we did. We have listed the distinct entries and then we have given the frequencies. Right. So each row of a frequency a category along with the number of cases in this category, right? So it puts the category and the number of items in the category, right? And what we did, so we first listed the distinct values and for each observation, we placed the tally marks and then we counted the tallies from each distinct values. Okay, so as simple as that. Okay, so frequency table is clear for everyone?
Yes,
Yeah.
ma'am.
Yes, ma'am.
Okay,
Yes,
let's
ma'am.
move to relative frequency now. So what is relative frequency? So the ratio of the frequency to the total number of observation is called relative frequency. What does it mean? So here, what do we have to do? So the first two steps are the same. First making the tally mark and then the frequency, that is the same. And then you have a third step. What is that third step? So first obtain a frequency distribution. So that we have to do, and then divide each frequency by the total number of observation. So here, for example, if we are proceeding with the same thing again, let me do it and show you, then you will understand it better. So for example, here we had 2, and then here it was 4, 4, 6, 4. Okay, so 4, 4, 6, and 4, right? So 2, 4, 4, 6, and 4. And you know the total is 20.
20.
Now, here,
It would be 2 by 20.
yeah, so we have to make
2 by
2 by
20
20. What is 2
2
by
by
20?
equal to
20.
0.2.
1 by
0.2.
0.5.
0.2, 0.4,
1 by
0.4, 0.6.
0 point?
0.5.
0.1.
0.1. 0
Okay, and 4 by 20 is?
Oh, I'm sorry.
0.2.
0.2.
2.
And
0.2.
again 4 by 20 is 0.2.
0.2.
And 6 by
2.
20
0.3.
0.3.
and
ma'am.
again
Yes.
4 by 20 you have 0.2. Now
0.2.
what is the sum of all the relative frequencies?
1.
1.
Okay, so this depends on the given data set, but this is always fixed. Okay, so this value here, see, this one depends on size of the data set.
So what if it becomes greater than 1 or less than 1? Can it
It
be?
means there is some calculation error. Okay, so this always
Okay.
depends on the size of the given data set, but this one, so always 1.
Yeah.
Whatever is the size of the data set, this is always 1, because this is just the kind of, we are like, suppose we are taking the percentages, then percentage always should sum up to 100, right? It cannot like probability or percentage,
Yeah.
it should always sum up to 100. So same way, relative frequency always add up to 1. Okay, so
Yes, ma'am.
Yes,
this
ma'am.
cannot change. All right. So I hope the relative frequency table is clear for everyone, right?
Yes,
How to
ma'am.
put the
Yes,
relative
ma'am.
frequency table.
Yes, ma'am.
Okay, let us see another example. So let's consider another data set which contains data representing the shoe size. Again, the similar kind of problem, but here just the data set is different. Okay, here already it is mentioned that this data contains only 12 entries. So let us see what are they. So what is the count for 5?
2.
1,
2 times.
2.
2.
again this is
2
again
times.
twice. What about 6
2 times.
Also
times.
2 times.
2 times.
and 7?
2 times.
2 times. 2 times.
2.
And then 8 is appearing
3
3
times.
times.
3
3
times.
times.
and 9 is appearing.
2 times.
3
2
times.
times.
3 times.
Okay, so here you see 2, 2, 2, and then 3, 3. So what's the total?
12.
12.
12.
And what are the relative frequencies? What is 2 by 12?
0.1. 2 by 12.
What is the answer for 2 by 12? The decimal
0.16.
0.16.
16.
1 6.
Okay, and what about 3 by 12?
0.25.
0 point?
0.25.
25.
25.
Okay, so now if you sum them up, what are you getting? Check this.
1.
1. Okay. All right. So here, you see that now here, let us say the shopkeeper is comparing the data from 2 different days. Okay. So this is the data he got from the first day, and this is the data he got from some other day. Okay. In general, he wants to understand what is the ratio of each of the sizes. Right? He wants to have a comparison. In general, which size is sold more and how frequently it is sold. He wants to have a comparison. this comparison we can easily make if the data size is same, but is 20 and the number
Ma'am,
is 12. So how do we easily compare them? Yes? Okay. So in such cases, relative frequency is going to be useful for us. So why do we need
total
frequency?
relative frequency of the data will be, I think, 0.98.
That is because we have truncated it, right? So what is 2 by 12 actually? 0.666 and so on, right? So it is
Okay,
the
ma'am.
truncation error. So this is because of the truncation, this is actually 1. If you are just adding 2 by 12 plus 2 by 12 plus 2 by 12, everything, it's automatically, it's going to be 1. It is because of the truncation error happening here, because here it is a long decimal value coming up, right? That's why.
Okay, ma'am.
Yes, ma'am.
Ma'am, got a question.
Yeah.
In the mod, you will learn something about round of error. Is it the same thing?
In round of what? Can you please repeat?
In the module,
Round of
in the
errors.
module, we
This is
talked
asking
about
about
round of error.
See, this round of error is going to affect when you are doing pie chart. Yes, you have to be very careful when you are going to do the pie chart, because this relative frequency is what you are going to use for pie chart as well. So you have to be very careful in that case. All right. So
So
here,
my question was, truncation error and the round of error, they're same or they're different?
sorry,
Like
what?
in mod, like truncation error that you mentioned right now, like it's happening here, and also the round of error we learned there, are they the same thing?
Yeah,
Is it
yeah. So the thing is that when we are doing this rounding off, then what is happening? We are just leaving it, leaving out some of the decimal values. Yes, they are same. Yeah. All right. Okay, fine. So yeah, now we know how to make a relative frequency table, and also why we are using a relative frequency table. So mainly when we want to compare data sets, we need relative frequency. And also usually you see that the values are between 0 and 1. So it is easy for comparison. So for example, let us say you are having the size 9, and here also the size 9. So here you see that the size 9 is sold, 25% of the purchase is from size 9, and here 20%. So more or less they are same, right? So in this way you can have a comparison. Okay, fine.
Yes, ma'am.
All right. So here is another quick question. So can you all just try it? Maybe I'll give you 2 minutes and then you can answer.
Ma'am, the answer will
Dice
be
B.
Okay. So here you see that first of all for
Dice B,
die A,
ma'am.
how many times
Dice
1 is
B.
appearing?
3 times.
3 times. So 1,
3 times.
so it is appearing thrice, right? So for die A, the 1 is appearing 3 times. But how many values are there in die A? How many?
20.
20.
20.
20.
3 by 20. And for die B, what is the relative frequency? So you have 1
2.
appear twice.
2
2
times.
by
2 by
By
10.
10.
0.2.
sorry, 2 by
10.
10. Yeah. So which value is bigger, 3 by 20 or 2 by 10?
2 by 10.
2 by
2
10.
by 10.
Yeah. So 3 by 10, 20 is actually 0.15. And what is 2 by 10?
0.2.
0.2.
0.2.
So you see that die B has a higher relative frequency. Is that fine? Yeah.
Yes, ma'am.
Okay, good.
Yes.
All right. So here is another exercise. A total of 2,000 cases of COVID-19 have been registered on 5th May 2020 in 5 key districts of Maharashtra. Okay, so the proportion out of 5 districts of cases in each district is listed in this table. Okay, so now the question is, how many cases were registered in Pune on 5th May? So how do you know how many cases were registered? What is the information given to you? How many, what is the total number of cases?
2000.
2000.
2000, right? So your n sum of frequency or the total data set size is 2000. Now you are
400, ma'am,
asked to
also.
find out.
400.
Sorry, what?
400.
400 also, ma'am.
Okay, so how do you
If it's
compute that
400.
400?
Ma'am, I just
Using relative
Relative
multiplied
frequency
frequency
in 2000.
formula, ma'am.
1000 with 0.2.
Yeah, so whatever is the number of cases registered in Pune, let us say it is X, and how do you find the relative frequency? You divide it by 2000 to get this.
Relative
So you see
frequency,
that X
frequency by
by
total.
2000 is 0.2. So what should be your X?
400. 0.2 into 2000.
100.
Okay, so
So
your answer is 400. Is this clear for everyone?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
All right. So everyone read this carefully. Give time for everyone to read. Don't be in a hurry to answer. When I'm asking give the answer, then you can answer.
Ma'am, option number D.
Option A and option B.
Okay.
Option A and option B.
Option D.
Okay. So first let us look at option
Ma'am,
A.
option A and
Option A. Option A.
Yeah, we will see each option one by one. So two data set having the same frequency distribution will have the
A
same
and D,
relative
ma'am.
frequency. Is it true or not? If the frequency distributions are
True.
same, obviously the relative frequency is also going to be same. Yes or
It's
no?
true.
Yes.
True.
Yeah. Now the second option B says
Yeah,
that
D,
two
ma'am.
data set having the same frequency distribution
actually is the
have. This is
Then not be
opposite
relative.
of this. So this is not correct, right? And two data set having the same relative frequency will always have the same frequency distribution. Is it necessary?
No, ma'am.
Not necessary.
Not always, ma'am.
No,
Sometimes.
Yeah, sometimes it may be same. Sometimes, for example, let us consider this example. Suppose let us say there is a data set containing 24 entries, exactly having the frequencies double of this. Then what is going to be the relative frequency? Exactly the same, right? So in that case, you see that the frequency distribution are different, but the relative frequencies are same, right? So in this case, you see that this is not correct. Why this is not correct? Is this clear for everyone?
Yes, ma'am.
Yes, ma'am.
Okay. And what about option D? Two data set having the same relative frequency can have the same frequency distribution.
It's true.
Okay.
It is
True.
It's true.
Right? Can have in the sense sometimes it is possible that they have the same distribution. Okay. All right. Okay. Now moving to the next topic.
Ma'am,
Yes.
ma'am, please can you explain once again option D?
Option D. See, for example, suppose let us say your frequency relative frequencies are same. Okay. So in that case, so there are two possibilities. For example, let us say you are having some data set. I'll take a very small example. Okay. So let us say you are having some A, B, C. Okay. So A is appearing 2 times, 1 time, and 2 times. Okay, and you will have some so total count is just 5. Okay, and you have some relative frequency here like 2 by 5, 1 by 5, and 2 by 5. This is one data set. Okay, now let us say you are having another data set. Okay, so in this case, let us say you are going to have a bigger one. So just the size is going to be more, right? It's going to be the same size. So yeah, so
Ma'am, what
here
is
you are going.
aggregate distribution?
Sorry, what?
Aggregate distribution.
Aggregate distribution. Where did you see this term?
Ma'am, in graded assignment.
Oh, okay, fine. We'll see that maybe after some time. Hold on. So here you have, let us say you are having 4, 2, 4. So the total count is actually 10. Okay. And here, what is the relative frequency? 4 by 5. And here you have again 4 by 10, 2 by 10, and 4 by 10. So here you see that these two are different frequency, having different frequency, but same relative frequency. Okay. So now let's come back here. Two data set having the same relative frequency. So both are having the same relative frequency. Okay. So suppose let us say the other second data set is also the same. Suppose you have a similar data set. That is also possible, right? So suppose on 2 days the same kind of purchases are happening. So you will have a same kind of data set again. So that is also possible. But it is not always possible. You can have something like this, which is different from this, but the relative frequency is same. Now, do you understand what's the difference?
So
Yes,
here,
ma'am.
Okay.
Yes, ma'am.
hello.
Yes.
So it can be same, it cannot be same.
See, it can be same,
Cannot be same.
but need not be
Same.
same.
Got it.
Okay.
So if I divide by if I divide 2, so then that calculation will come 2 by 5 in second
Yeah.
set.
Yeah. So this relative frequency is exactly matching with this, right? Okay. Fine. Okay. So shall we move on?
Yes.
Okay. Good.
Yes.
Yes, ma'am.
Okay. Now here we are having what are how to represent categorical data in chart. Okay, fine. So in for categorical data, what are the most common type of charts used for visualizing categorical variable? Bar chart and pie chart.
Pie chart.
Okay. And the other one, which is the Pareto chart, is more or less like bar chart, just that they are aligned in a different way. Okay. So basically bar chart and pie chart. Okay. So both can be obtained from its frequency table. So the frequency table is always the first step. Okay. All right. So how do you make a pie chart? A pie chart is a circle divided into pieces proportional to the relative frequency of the qualitative data. Okay. So what does it mean? We'll see again with an example, then you will understand it better. So we are considering the same example, the first example which we have considered. We know that this was the frequency and these are the relative frequency, right? Now, how do you make a pie chart? For that, what you have to do is that you have to do it like this. You multiply the relative frequency with the number 360. Why 360?
Because
Why
the
360?
circle has angle
Circle
of
is at
360 degrees.
Because
Right?
pi is a circle.
Yeah, one complete circle means it is having
Circle is 2 pi, so 2
360
into
degrees.
180 will be
Yeah.
To
360.
make an pie chart,
180 is the
Pi 180 means it is just half, and now you have the entire circle, so 360 degrees. Right? So you are going to divide a circle, okay, into now 5 different pieces. Now what is the, so you call this as a section, right? A sector. So now each of this small section, like how many, what is the angle for each of this section? That is what we have to find. So to find the angle for each of this category, you just simply multiply the relative frequency with 360. So you see 0.1 into 360 will give you 36 degrees.
36
and
degrees.
0.2 into 360?
72.
72.
So you have 72 again. And then what is 0.3 into 360?
108.
108.
108.
And again here 72.
72.
So now again here, this is a very important step. So what is the total?
360.
60.
360 degree.
360.
Okay. So always,
Yes, ma'am.
so here this one, always verify if the sum is 360. Okay. So here, since we are not having a pen and paper exam, you will not be asked to use a protractor and then make a circle and all these things. But you should know that you should use a protractor and make this kind of degrees. So here you see that this part here we are having, this is 36, okay, and these are all 72, right, and the bigger one is 108, right? So here you see these are called the labels, okay? So what you see here, so these are the labels, right? So every pie chart or in general, any chart should have a label. So you see this is representing 5 and this is representing 6, 7, 8 and 9. Okay. So this is how we make a
Yes,
pie
ma'am.
chart. All right. So how a pie chart is made, that is clear for everyone, right?
Yes, ma'am.
Yeah.
Yes.
So
Yeah.
here I
Yes,
want to
ma'am.
ask that you have made this chart in a pie. So what if, because here like 5 data set is there, not data set, 5
Distinct values are there. Yeah.
distinct value is there. So can't we make it as a line chart?
Yes, you can also make a bar chart. That is also possible.
No, line chart.
Why do you want to make a line chart here? See, the thing is that here, mainly, particularly if you are considering bar graph or a pie chart, so the specific purpose of a pie chart is to see within a specific group, okay, what is the proportion in which each of this group is distributed. Okay, suppose let us say you have 24 hours. In the 24 hours, how much time you are spending for each task? And that you want to represent, which graph you will choose automatically pie chart. Because that, suppose you are having, this is kind of one inside one group, inside one day. What is the splitting of each task? Similarly, inside one set of data, which is the set of all shoe size. So you want to see how much each of these shoe sizes are contributing to one day purchase. Okay. So if you want to look some comparison of one particular group, then pie chart is always the best way to understand what is the proportion of each part inside a specific group. Okay, you understand why pie chart makes sense?
Yeah.
Yeah. All right. So here is an example. Everyone go through this.
Yeah, here that question is asking that that manufacturing company in like expenditure for the month of October is around 50,000.
Shipping charge is 50,000.
Yeah. So
10 lakh,
here,
ma'am.
yeah. So here, how do you find what is the total expenditure of October? How do you find this? So here, first of all, you see that the percentages are given. Okay. And you know that, so if you are having a pie chart, what are these percentages representing? You already know, right? What do you know about these percentages? How are they calculated? So you have to just go back here. Right? So you can represent the same in terms of percentage, right? So this is 10%, this is 20%, this is 20%, this is 30%, and this is 20%. So this is the relative frequency also gives you the percentage, right? So now, can you tell me what is this 25, 15, 20, and 40? All these are representing.
It's written in
Relative
small
frequency.
size. Relative frequency.
Yeah, yeah. So now they are mentioning that 50,000 was spent on shipping. Okay, so where is shipping? So yeah,
It's in
so 5%.
green color.
5%.
Yeah, so 5% is spent on shipping. So what should be the total expenditure?
Ma'am, 10 lakhs.
Can you do this?
10 lakhs, because 50,000 is 5% of 10 lakhs, so it is the answer.
So 5% is simply 5 by 100, right? And how
Right.
do you get this 5 by 100? So how do you obtain the relative frequency?
Frequency by total equals to
Frequency by total
relative
number of
frequency.
Yeah, so you have the frequency, which is the value which is given by 50,000, right? So the value is given by 50,000 and this is
10,000.
divided by total This is your 5 by 100. Now, how do you compute the total? What is the total if you calculate from here?
2000 into 100.
10 lakhs.
10 lakhs. Right? You have 10 lakhs. Okay. Is this clear? How are we finding this total? Is this clear for everyone?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Good. Okay. So here is another question. Read this question.
Statistics class. How many students have B grade in the T students?
26 students.
26.
Okay, so let's see how you
Yes, ma'am,
come up
26.
with the answer. So here the distribution of grades in a statistics class consisting of 80 students. So here they have already given the total is 80. Okay, and now how many students have secured B grade? So which color is represented B?
Grade.
So this one is representing
32.5%.
B. Yeah. So B grade is 32.5%.
32.5%.
Yeah. So 32.5 is coming from the core
80 student.
80%.
right, total. Right. So here you see the score of the student. How many students? Okay, not score. How many students? Number of students by total. So number of students. Okay. And that is what we don't know. So let's call it maybe X. So X by 80. So what is your X in that case?
32.5
80 into
into
32.5.
Which is what's the
26.
Also divided by 100.
26.
26.
20.
All right. Okay, fine. So this problem, is this clear?
Ma'am, but 32.5 by 100 into 80 should be there.
Divided by
Because,
Yeah, I missed that 100. Yeah, thanks for pointing.
divided
So,
by 100, ma'am.
yes. Because it is given in percentage, so we should be careful. So because it is percentage, we have to write 32.5 by 100. Yeah, good.
Yes.
Okay, so this is the answer. Okay, so I hope understanding pie chart is now clear for everyone, right? Yeah.
Yes.
yes, ma'am.
Yes, ma'am.
There is just one more question regarding pie chart. So pie chart is used to which of the following? Show the proportions of a categorical variable. Is that true?
Yes, ma'am.
Yes, ma'am.
True.
Okay. Divide a circle into pieces which is proportional to the relative frequency of the qualitative.
True.
Correct. It's correct.
Okay.
Yes, ma'am.
Compare proportions of a whole.
True.
True.
It is true.
True.
So A, B, C are correct.
Okay. Good. So these are specific, basically the characterizations of a pie chart. Okay. Maybe we can say why we need a pie chart. These are the reason, right? Okay. So moving on to bar chart now. Okay. Bar chart is much more simpler than a pie chart because there are no angles to compute. Okay. Straight away from the frequency table, you can easily make a bar chart. Very easy. So a bar chart displays the distinct values of the qualitative data on a horizontal axis and the relative frequency or sometimes all the percentages of those values on a vertical axis. So either the frequency or relative frequency of each distinct value is represented by a vertical bar whose height is equal to the frequency or relative frequency of the value. Okay, again, so let's look at an example and then we'll go back there. So we are taking the same example. So usually along the x-axis, we are usually representing the distinct values. Okay, so here in this case, the label for the x-axis is shoe size. And what are the distinct values?
5, 6, 7, 8, 9.
7, 8, and 9. All right. Okay. And now you have 1, 2, 3, 4, 5, 6, 7, 8. So I have made up to 8 just to make sure that all these frequencies are covered. So the y-axis, this represents, what does this represent? Y?
2
Frequency.
frequencies.
What
Frequency.
frequency? So the label can be either you can write frequency, or you can also write the number
Relative frequency.
of shoes sold. Okay, so both of them, what is the frequency representing, that also can be written here. Okay, fine. So now we are going to see what is the bar length of the bar in each case. So for 5, the length should be 2. So here you see the length is 2. Okay, all right. And then here for 6, the length is 4. Okay, and for 7, usually you should use a scale, so it should look nicer than this. So 7, again it's 4. And then for 8, it is 6. Okay, so here 2, 4, 4, 6, and then again for 9, it's 4. Okay, so this is how usually a bar graph is made. All right. And of course, inside also the color is filled, right? I don't know whether that much detailing is needed, but anyway, maybe if it's not working, maybe it's better I avoid this. I don't want to complicate things. I hope this is enough for you to understand. Of course, any chart should have a title, so maybe you should have a title saying the number of shoes bought based on the sizes of the shoe, something like this. You can give a title. So here you see, first you obtain a frequency or relative frequency table, and then in the horizontal axis, so you draw horizontal axis and vertical axis, right? So on the horizontal axis, you place the distinct values. You construct vertical bar whose height equals to the frequency or relative frequency, okay? And label the bars with distinct values, okay? And the horizontal axis with name of the variable, okay? So yeah, so this is the name of the variable, and vertical axis with frequency, okay? So how to make a bar chart, is it clear for everyone?
Yeah.
Yes, ma'am.
Yes, ma'am.
Since you don't have a pen and paper exam, the process of explaining these things are like, it's very short, I feel. When I teach the students in person, I have to tell them, take the scale, take 1 centimeter, take 1 centimeter gap and all those things. So you guys don't have to worry about all these things, right? Okay.
Yeah.
So you don't have to use a protractor. You don't have to use a scale. Okay. So yeah. Anyway, so now let's see an example here. A study conducted in the last 10 years shows how students choose different streams after completing 10th grade. This is a very basic question. The outcome of the study is given here. What percentage of students have chosen biology or politics?
20%.
20%.
20%.
Okay,
Okay, ma'am.
why 20?
Because it's either biology or it's either politics.
Biology, 10 or
biology or
politics.
politics, so 10 plus
10%.
10 will be then 20.
Here you have 10, and here you have 10, so 20. Okay, so 20.
But it is or, right?
Sorry?
Your question is saying that or biology or politics.
Yes,
It's
ma'am.
not saying that
Means
and.
either
10%.
either biology or politics.
Then the answer should be 10%, right?
Yeah, or means either.
It should be 10%.
So here, I guess it should, see, if we are looking at, if we are using probability exactly, then either means here the person can either be here or here, right? So in that, so how is that?
According to the addition rule of probability, I think so. It is solved.
Yeah, that is what I am also thinking. But what is the solution given? I don't know. In the PA, this is a PA question. I
Yes,
did not.
ma'am, it's 20 given.
20,
I-
right? Should be
Yes,
20.
Ma'am, it's given that one.
Yeah, so based on that rule, this should be 20 only, right? Oh,
You're saying in question asking that or
yes.
biology or
Or means
politics.
union. So, or in the case means it is union, right?
Ma'am, union of events will be addition rule of probability. So
Yeah, so if you are doing union, then it should be addition only, right? Yeah.
Yeah.
So it should
So
make sense.
instead of or, if I would get that and, then maybe it could be
Multiplication.
different.
then it would be intersection. So
Yeah, and means it
multiplication
is
rule.
intersection, right? Chosen biology and politics will be 0, right? There is no one who has chosen both biology and politics. That will become 0, right?
Yes,
Oh,
yes.
got it.
Yeah.
Ma'am, help me with aggregate distribution. I stuck in this problem.
See, okay, I don't know what is that problem exactly. So in general, what is aggregate distribution? Maybe quickly, see, this is a kind of something in between is going on. It's not a good way to do. Usually, I recommend all the students to ask the doubts at the end of the session, or specifically, we also have a doubt clearing session. But since you are asking the second time, just this time I'm saying aggregate data is not the complete data set given, but instead you are given kind of the summary of the data. Aggregate in the sense summary. Suppose let us say, so the same shoe data set. So instead of giving you the data, now I have given this. This is kind of an aggregate data also, you can say. I'm not, suppose instead of giving this 5, 6, 7, 8, how many times it is appearing. Suppose I'm saying that, so there are totally 20. Okay, and highest frequency is 6. Okay, so something like this I'm saying. Okay, so only this kind of like specific information is given. Okay, kind of a summary is given, but not the original data. So this kind of data is usually called aggregate data. So
Ma'am,
in
may I ask one question from this data? Like here shoe size given, right?
yeah,
And what will be the aggregate distribution of 5, 6, and 7 number shoe size?
there is what is aggregate distribution?
What will be the aggregate distribution of 5, 6, 7 shoe size is?
See, there is nothing called aggregate distribution. It's just aggregate data.
I mean, in
Yeah,
question,
aggregate data in the sense that suppose you want 5, 6, 7, then the total number you take just as 10. And in that highest frequency or median or, see, usually some descriptive measures is also given in an aggregative data. So the median, mode or something like that. So for categorical data, it is given. And for numerical data, mean and total number. So something like this, like that is also given. Okay, just this is what is usually referred to as aggregate data. I don't know the specific problem you are talking. So this is usually
ma'am,
the aggregate data.
in graded assignment, marks of 5 subject is given and asked the aggregate distribution of the 3 subject, physics, chemistry, and maths.
Aggregation means like count,
If the
sum,
exam
max.
is
These things are aggregation.
Okay, so maybe we'll do one thing. So after
pie
at the end
chart,
of, please let's not interrupt the flow of the session. I understand you have a doubt. Maybe we'll have a look at the same question at the end of the session, or even better during the discussion session, which is going to happen on Tuesday. So I will definitely answer your question, but not disrupting the flow of this session. Okay.
sorry, ma'am.
Okay, that's fine. All right. Okay, so here, now we are having Pareto charts. Okay, the next topic is Pareto chart. So far, we have already seen pie chart and bar chart. And Pareto chart is again another bar chart. Only now the frequency are sorted in decreasing order. Okay, So if the categorical variable is ordinal, then the bar chart must be preserving the order. Okay. So here you see that it need not be ordinal. Even for this case, so the same can also be given as a Pareto chart. So for example, what is the frequency? Maybe here, what is the frequency? 6 and then 4, 4, 4 and 2. So the same, if I'm instead of doing like this, so suppose I'm going to represent 6 first. Okay. And then I'm going to represent, let's say 1, 2, 3, 4, 5, 6. Yeah. So suppose I am going to represent 4, 4. This is just an approximate graph, not a very nice graph, but anyway. So, and then you have 2. Okay. So the same data is now represented based on the frequencies. Okay. So this is a Pareto chart. Okay. So you see that for this given data also, this is possible. Okay. And the same can be done for any kind of bar chart. Okay. Pareto charts are popular in quality control to identify problems in a business process. Okay.
Can we
So
explain one more time that about the Pareto charts, how it look like?
which one?
Pareto chart.
Pareto chart is going to look like this. So in kind of a always skewed graph. So always you have this increasing, decreasing order. The chart is going to be arranged.
Ma'am, it must be in decreasing order every time, right? We can't
Yes,
arrange
yes.
Pareto chart in increasing order.
Yeah, yeah. So usually it is arranged in this way. Okay. All right.
And what about that frequency?
The frequency are just the same. They are not going to be differing. Only based on the frequencies, the ordering of this labels here. So whatever you are going to choose here, that is going to vary based on the frequency. Okay. All right. So here you see that. So here you 5, 6, 7, 8, whatever is there in the table is used for bar chart. But here when I'm applying a Pareto chart, I take the one which has the maximum frequency first. And then the next frequency is 4. So I took all the shoe sizes with 4, 6, 7, 9, and then the least comes. Okay.
We cannot have it in the ascending order.
Usually Pareto chart is made in this way, in descending order.
And but if question comes and then it is asked that when the options are given that you either arrange in the ascending or descending order.
See, you
Because
can arrange a bar chart in any order you want, but this kind of an order is called a Pareto chart. That's it.
okay.
Yeah, Pareto chart must be in descending order, not increasing.
Okay, fine. All right.
In ascending order, not descending.
It's descending, right?
Descending.
Oh, someone said ascending? Okay, fine. All right. So here you see that. So we are having pie chart, bar chart, Pareto chart. All of them are representing categorical variable. Now, given our data set, how do you identify which graph you should be using? Okay, so for that, you should understand what is the purpose for which you are using the graph. Okay, so every table or graph should have a purpose. What is the purpose behind the table you are using? So suppose you are going to compare parts of a whole, as I mentioned earlier. Okay, so in that case, pie charts are best. Okay, and bar graphs are used to compare things between different groups. Okay, so suppose let us say you want to understand what is the rainfall across different regions in a state. Okay, in that case, pie chart does not make sense at all. In that case, bar chart makes more sense. Okay, and also suppose let us say you want to see the number of different subjects. Yeah, just subject example somewhere. Yeah, so this kind of a thing. So here also you see that bar chart makes more sense than a pie chart, right? Okay, so here is another question. Can you all go through and see whether you are able to answer this question.
Yes, sir.
The
B and C.
analysis wants to represent the revenue of the various companies using graphs. Like various companies has the different revenue, and then we have to analyze and which of the following graphical representation and most of the appropriate for the purpose. So whatever we have to find, like we analyze the revenue, like yeah,
B and C.
across the companies we made the revenue.
Yeah, so they are like, we are considering revenues from different companies. Okay,
Yeah.
so which one is going to be more appropriate?
C.
Bar.
B and C.
Bar chart.
Okay.
No,
So
it
bar
depends.
Yes.
chart, the
It depends.
specific
Like,
example where I have given, it is a vertical bar chart. You can also have a horizontal bar chart, right? Okay.
but
Right, ma'am.
like what if
D, I think.
I'm analyzing for three companies. For that
So
case,
you are analyzing what?
if I'm analyzing the companies for three, suppose if I represent the revenue of the three company, then pie chart is good now.
See, it's not about the number of companies. It's about, see, here they are going to be different companies. So what are you going to see? Pie chart means, as I told you, the sum is kind of fixed. Okay, so for example, you see that the total is kind of a percentage. For example, as I told you, if you are comparing the total number, the representing a day, the hours spent in a day, it's kind of fixed. And also here, suppose you are representing, suppose, let us say, what is the other example we have used for pie chart here? Yeah, so here you see that in the total of 80 students, what is the distribution we are seeing? Inside a specific group, what is the distribution we are seeing? How much each part of this group is classified into different parts. That is where pie chart is going to make sense. Now we are not doing something of this sort, understanding the proportion in which a bigger group is divided into. That is not what we are doing here. We are just looking at the revenues of different companies. They are not even related. Right? You understand?
That's what, like every company has their own different revenue. So if I analyze only revenue, we can use pie chart. No?
Suppose you want to say, suppose the question is something like this. The revenues from different departments of one company is represented, then it at least makes sense. You are comparing the entire revenue and what is the share from each department, then a pie chart will make sense. But you are comparing the revenues from different companies, it's not going to make sense. Okay? Understand the difference?
Yeah.
Yeah. So here, bar chart is a more suitable option. So this maybe I have not mentioned. So a bar chart, the same thing. Okay, you can just, so here you are having x-axis and y-axis. So you can also have it in this way. So the same graph just maybe rotated 90 degrees. So the same can be represented in this way as well. Okay, so what happens here?
This is called horizontal bar chart.
Yeah, so here what have they mentioned? A bar chart with a bar for each company on the x-axis and the length corresponding to its revenue in the crore rupees on y-axis. This is the usual one we are making. So now here they are just reversing their roles. A bar chart with a bar for each company on the y-axis and the length corresponding to its crore on the x-axis. So it is just the position is kind of interchanged. Okay.
So, ma'am, which one is more appropriate, horizontal one or the vertical one?
It depends on your convenience, how you want to visualize. It depends just on the convenience of the user. Both
ma'am,
are.
we can select B and C, right? Yeah,
Sorry?
B and C.
Yeah, both are correct here. Okay. A bar chart with the minimum revenue as a baseline. What is a baseline? Baseline is this one. So this one. So this should always be 0. Okay. This should always be 0. And in some cases, if it is not 0, what has to be done? That we will be discussing shortly. But usually that is 0. Okay. So if you are taking minimum revenue as the baseline, then that is going to give you a biased graph. Okay, it is not going to give you a good graph. Okay, so this is of course incorrect. Okay, fine. All right. Yeah. Have a look at this.
Yeah, 200 movies. I think.
Ma'am, it is Pareto chart. That's all we can put.
Yeah. So you can easily, from a Pareto chart, it is easy to visualize which where revenues are more. Right?
Actually, it's easy to rank movies according to the revenue.
Yeah. So Pareto chart is more suitable in this case. Okay, fine for everyone. Why Pareto chart? Yeah. All right. So here, the next thing is about, so how you should make your charts more like understandable, and also how to avoid errors in the chart. That is what we are going to see now. Okay, so the first thing is that always you should label your data. Suppose the same bar graph is there without these labels, mathematics, biology or something. Will this bar chart make sense?
No.
No. Similarly, if you are going to make this pie chart without having this labels, this legends you are having, A, B, C, D, will it make sense? No. Right?
Other person will not understand.
Sorry, what?
Other person will not understand, na?
Yes. So the labels are very important to understand a graph. So you should always label your chart to show the categories and indicate whether some have been combined or omitted. Okay. So suppose, for example, we have not yet covered that part. So for example, suppose let us say you are having, so let's say so many different categories. Okay. So many different categories are there inside a specific group. Okay. So let us say there are like 30 different categories are there. Okay. And majority of the categories fall under 10 categories. Majority of the count falls under 10 categories. 10 major categories. So we have only 10 major categories. So this is our main focus. So in that case, what we can do is that, so we can just, for example, I don't know what is the name of the category. So maybe I'll give some name like category 1, category 2, category 10. So these 10 categories, I'm going to display what is the actual value. Okay. And for the remaining, okay, instead of just adding C11, C12 up to C20, I'm just going to put others and just represent it in one bar. This can be done when my focus is on some specific part. So in that case, this is what it means by combined or omitted. Okay. So if you are combining certain part, then that should also be mentioned. Okay. Fine. And name the bars in a bar chart. So you should also name the bars. So each bar should be named, and the slices in a pie chart. Okay. And if you have omitted some of the cases, make sure the label of the plot defines the collection that is summarized. Okay. So this collection, others, what is meant by others, that should be also explained. Okay. Others means, so maybe from C11 to C30. So that comes under others, that should be mentioned. Okay. So for example, here you see labelings are very important. Okay. So now can you read this exercise and see whether you can answer it?
First one.
Option number C.
Incorrect.
Okay. So first option says that bar chart is a better tool to describe the gross domestic product growth rate of India from 2009 to 2020. Yes, this is actually correct. Pie chart is not effective when we have large number of categories. Is that true?
Option C is
True.
C is
Yeah.
the correct answer.
Yeah, Pareto chart is used only for ordinal data. So,
That is wrong.
yeah,
Incorrect option.
yeah. So maybe I should say instead of putting a tick, that will give a wrong impression. So this is, I can say this is correct. And this is also correct. But this is wrong. Why this is wrong? This is because Pareto chart, as I mentioned, can be used for either nominal or ordinal. Okay. So it is not correct. So it can be used for nominal and ordinal, both. Okay. Bar chart is better than pie chart if we want to compare the actual counts. Okay. So suppose we are comparing just the counts. Okay. Then we are bar chart is better than pie chart. Okay.
Yeah,
Not
that
the
is
ratio,
true.
but the counts. So this is also correct. So this why only C is incorrect and others are correct. Is that clear for everyone?
Yes.
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay. So here you are having some data. Go through this question.
Ma'am,
Yes.
could you please explain option A
Option A. Yes.
of exercise
Please
12?
scroll down.
Yes,
Can you
ma'am.
scroll down?
This one?
Yes, ma'am.
One, right?
Yes, ma'am.
See, here bar chart is a better tool to describe the gross domestic product GDP growth rate of India from 2009 to 2020. In different years, what are the different GDP you want to see? Okay. So now this is just a count. It is not going to compare within a specific group. So this is just basically explaining the counts. So bar chart is definitely a better tool to understand this. Okay, not pie chart. Is that clear?
Okay, ma'am.
Yeah.
Yes, yeah.
Here we can understand that how much GDP has been made.
Yeah, in each year. Yeah.
Ma'am,
Okay.
this is wrong pie chart because there is no level. We can't understand what percentage of petroleum, fertilizers, and everything.
Yeah, labels are missing, right? Labels are missing. What is this each of the sector representing?
Yes, ma'am. For each category, it should be
Yeah.
labeled.
So here, which answer is the correct one?
Ma'am, what's
No
less?
legend.
There's
Option
no
B.
less.
B.
Option B, no legend.
Okay. So here you already have a title. So what is the meaning of this option D? So this kind of a chart you might have seen. I don't know whether I have such an example. Yeah, like this one exactly. So you see that sometimes a pie chart might have something like this, right? So maybe they want to particularly highlight that particular part and they show it kind of protruding out of the circle. So that they say it is offset from the center. Okay. And that is not required in this graph, right? That is not a problem in this graph. So all this point, what it means and why they are correct or incorrect, is it fine for this particular problem?
Yes,
Ma'am, what's legend?
Yes, ma'am.
What?
What's legend, ma'am, in option B? There is no legend. What does it mean?
Option D.
B, ma'am, B. Legend. There is no legend. What does legend mean?
This is called legend, where I have used legend somewhere. Where is that example? Yeah, so this is called legend.
Okay, ma'am. Thank you.
Okay, fine. So next comes what is the area principle. Okay, so displays of data must obey a fundamental rule called the area principle. Okay, so the area principle says that the area occupied by a part of the graph should correspond to the amount of data it represents. Okay. For example, you look at this pie chart. Okay. So this is the pie chart which we usually make. Sometimes this kind of pie chart is also made. Okay. But we have to make sure that it follows the area principle. Okay. Why this is misleading? Because here you see that item C is actually just 5%, whereas item A is 11%. But when you look at this graph, it looks like item A and item C are more or less of the same size, right? Which is kind of misleading in this graph, right? So because of this, we say that there is a violation of the area principle. Okay, so the area it actually should represent is not there. It is representing kind of a bigger area in this chart, because of which we call this misleading. Why this is misleading? Is that clear for everyone?
Yes, fine.
Yeah. So the same thing we can observe in case of bar chart also. Suppose you are having two different bar charts representing the same data here actually. But you see that here, this value is actually representing 108.6 and this is millions and this is 101.7 million. Okay. And it is the size is kind of half of this. Does it make any sense? 101 and 108, what's the difference? And you see the level is kind of half of this. It does not make sense, right?
Yes,
Yeah.
ma'am.
And you see this chart is making more sense, right? This is how it should be actually represented, right? So here you see there is a violation of the area principle. Okay. So you understand what is meant by area principle and when it is violated. Is that clear for everyone?
Yes, ma'am.
Yeah. Okay. All right. So the next thing is that what are truncated graphs? Okay. So another common violation is when the baseline of a bar chart is not at 0. Okay. So here what happens, the baseline, as I mentioned, it is usually starting at 0. Sometimes for some people, if they want to, let's say, exaggerate certain things, then what they can do, they can just truncate this part and just show this part. Then what happens? You feel that the difference is huge. But whereas if you look at this graph, you will not feel the difference is huge. But the same thing, when you are truncating this part, you feel that the difference is huge between south and west, right? So this kind of error should not be there. Always the baseline should start from 0. Okay, so here you notice that the left graph exaggerates the number coming from the south and north. Okay, graph on the right shows shows same data with the baseline at 0. Okay, all right.
Yes,
And
ma'am.
sometimes, yeah.
Ma'am, I have a doubt that what's the difference between the truncated graphs and manipulated y-axis?
Okay, see, truncated graphs actually basically leads to manipulated y-axis. Why? See, let's see. When you are having this 0 here, you don't have any truncation. Okay, but here you are having truncation, which leads to manipulated y-axis. What happens to the manipulated y-axis? Here you see that here the difference between these two values looks kind of huge, which is kind of manipulated. This is one sense. The other sense is that sometimes what you see here the scale, what is the scale they have used, we are not sure. This is also a kind of a manipulated y-axis only. Okay, so both these cases are manipulated y-axis, but sometimes manipulated y-axis or sometimes or mostly comes from a truncated graph. Okay.
Thank you.
Yeah.
So, ma'am, is truncated graph is wrong or what?
Yes, truncated graph is wrong. If you are truncating, there is a specific rule of how you should truncate. That is the next point actually. So suppose you want to truncate certain part, then you have to indicate it. Without indicating, if you are truncating, it is incorrect. Okay. Suppose, let us say, for example, in this case, so for this X4, whatever is this X4, this is kind of in 1400. It does not make sense to just simply, and other categories are just falling below this value, right? And it does not simply make any difference if you are putting 400, 600, 800 and then 1000. Okay, so you are just truncating this part and then you are indicating this break. So this indication, truncation is fine, but without indication is incorrect. Okay, So truncation, if it is made, should be indicated, otherwise it is an error. You understand? Yeah?
Yes, ma'am.
All right. So mostly this truncation is, this break indication at the baseline is also seen in certain places. So when all the values are like very high, in that case, you see that the baseline itself is truncated. Okay. Suppose let us say we are talking about salary of a specific company and the salaries are starting somewhere in lakh. Okay. So in that case, you don't have to start from zero. You can start somewhere where the baseline makes more sense. Okay. So in that case also, again, this indication is required. Without the indication, it is incorrect. Okay. Fine. All right. So yeah. So here is the next question. Everyone, please go through this question.
Ma'am, it is misleading because a graph is
Ma'am,
not
baseline.
Okay, so let's see. A
Misleading
teacher
graph.
conducted a statistics exam for 100 marks and the marks obtained by the students are plotted. Choose all the categories of misleading graphs. Okay,
Ma'am,
you
also
need-
misleading because there is a total marks is 100 and there is a 200 in total is showing. So
yeah. So here they are putting up to 200, which makes this value look very less. Okay, that is
Ma'am,
also there. And
misleading
Ma'am,
also
it also has a missing baseline. So
yeah,
it is
yeah.
truncated and misleading.
Both this and this, right? This is incorrect. So we have both missing baseline and manipulated y-axis.
What
So
is
here, why manipulated y-axis? You can see that, see, if you have stopped here, then you are the same graph. Okay, so same graph, if you have stopped here, then it is going to look like many students have scored high marks. But now since your y-axis is going till 200, it feels that most of the students have got very less marks, right? Which is kind of misleading. Okay, that is because of the manipulation of y-axis. Is that fine?
Yes,
Yeah, why these two both of them are correct? Is that fine for everyone?
yes, ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
And then round off errors. What are round off errors? Okay, it is important to check for round off errors. This is something which I have mentioned earlier. So when we are calculating percentages or proportion, the total value slightly differ from 100 or 1, like 0.99, 99, something like this you are getting, right? So when you are now using this for pie chart, then the total may not sum up, right? So what is the total in this case? Can you check?
It's 92.
Yeah, so you have to be very careful when representing it in the graph. So you have to be very careful to check the round off errors. Okay, so you should adjust the percentages in such a way that the round off is not, the round off errors are not too much. Okay. All right, fine. So these are the things about understanding and how to make a good graph. Okay, how to make a graph first of all, and how to make a graph without errors. Okay, that was the second part.
Ma'am,
Yes.
I joined
101.
late. I joined now only. What is manipulated y-axis?
Can you please talk loudly?
I joined now only. I joined
Okay.
late. What is manipulated y-axis in round of errors?
Okay, so first of all, yeah, I understand that you have a doubt, but it is recommended that you should go back and watch the lecture. But since we just completed this topic, I'm going to tell it. Okay. Manipulated y-axis in the sense that, so there are several different scenarios in which this manipulated y-axis can happen. One is when you see that, so suppose for example, I was showing this example. So here you see that this is 108 and this is 101. The scale what you are using is not kind of making sense because here 101 is looking like 50% of 108. So here you see that the y-axis kind of manipulated. And also you can consider this particular example. So the total itself is 100. So all the scores are just out of 100. But here you see that in the y-axis, you are considering up to 200, which makes us feel that all the students have got very low marks. Okay, so this is kind of another manipulation of y-axis. And another thing, sometimes you see that, so let us say the total marks is just between 0 and 100. Okay. And now if you are making the intervals, suppose let us say 0 to 50 and then 50 to 100, then what are the values of this graph? If the size between this intervals is gap is also too much, then also we can say manipulating y-axis is happening. Manipulated y-axis error is happening. Okay. So these are the scenarios in which we can observe manipulation of y-axis. All right. Okay. Okay, so everyone can go through this question now.
Ma'am, it is manipulated because it is not total 100. It is more than 100, I think.
Okay. What about the others? Are you all able to see? First of all, here are the options.
Yes, ma'am, it's adding to 102, so it will be
Option.
It disobey area principle too.
Firstly, the pie chart is misleading because it has rounded off.
Here the error is because of the round off error, right? So because here the total, so the total is
The
not
total
added.
percentage is 102. So it's
Doesn't add up to
it's
100.
wrong.
So this is the
It's
round
more
off
than
error.
100.
So here the error is because of rounding off. Okay, not because of any other issues. Okay. So is this problem also fine for everyone?
Yes, ma'am.
Yes.
Yes, ma'am. It's pretty
Yes.
clear to me.
Okay, good. Okay, so moving on to the next important topic. So now for summarizing categorical data, so we have seen graphical summaries, right? Bar chart and pie chart. So the next way to summarize categorical data is using descriptive measures. What are descriptive measures? So here for categorical data, we are going to see what are mode and median, which are measures of central tendency. Okay, so they are kind of some measures of central tendency. Okay, so it is kind of the center or most typical value of a data set. Okay, so first we'll understand what is mode. The mode of a categorical variable is the most common category. Okay, the category with the highest frequency. Okay, so the mode labels the longest bar in a bar chart, the widest slice in a pie chart. So how do you identify the mode? From a bar chart, it is the longest bar, and from the pie chart, it is the widest slice. Okay, and in a Pareto chart, the mode is the first category shown because it is in descending order. The mode is the first category in Pareto chart, right? So for example, here you see a bar chart. So in this, which one is the mode?
Blueberry.
So blueberry is the okay. And for the pie chart, which one is the mode?
Painting.
So this is the
painting.
So this is the widest slice and this is the longest bar, right? All right. Now, it is not that only one mode is always there. Sometimes there are more number of modes. So it means more than one category can appear as the category with the highest frequency, right? For example, here, let us look at this specific example. So here, what is the favorite sports of a group of students is observed. And we see that football and volleyball are having the same number of students, right? 20 and 20, right? So what is the mode in this case?
Bimodal.
Oh,
Both are mode.
Football
So this is
and
the
volleyball.
Football and volleyball.
bimodal data, right? And it is not just there are two modes. Sometimes there can be two mode, three mode, more than two is also possible.
yeah, multimodal.
Yeah, multimodal, right? So ordinal data offer another summary, the median. So for any nominal data, we can always find what is mode. But for ordinal data, we can have another summary, which is called the median. Okay. So this is possible only when we are able to have a specific order of the given data, right? What is the median? The median of an ordinal variable is a category of the middle observation of the sorted values. Okay, once you sort, so this is very important. Only after sorting you can find the median. Otherwise, the median is not going to make sense. So you first sort them and then you find the median. Okay, so many times students forget to do this step. They just straight away look at the position and write the answer. Sorting is very important step. Okay. So here I have given some examples to understand how to find median. So here is the survey results of 13 students. Maybe they are saying about a course, whether it is good, bad or something. Okay. So here this is the survey result. Okay. So now how do we arrange them in a specific order? Can you tell me? How many very poor are there?
4, maybe 4.
Very poor.
One.
Very poor, only one is
One.
right. And then after very poor, what is the next one should come in order?
Poor.
So how many poor are there?
3.
1, 2, and 3. All right. After poor, what should be in order?
Good.
Good or fair?
Fair, ma'am. Fair should be there.
So you have 1 and 2 fair.
2.
Okay. And then after fair, it's
Good.
good. So 1,
2,
2,
3. No,
1,
2.
2.
Yeah, 2.
And then
Very good.
very good. Very good comes
3. Oh.
3.
2, 3. 3 times.
Yeah.
Right. So very good. Very good.
It's actually 4 times.
And then at last,
Excellent.
Excellent.
Only one time.
right? Here in school, many of you
Very
showing
good is
notebooks.
4 times.
Yeah,
Very good is 4 times.
4 times. Once,
Yes,
twice.
ma'am, because one value is missing.
Correct. So this one, yeah, yes, correct.
Yeah, I had counted right at first.
Correct. So many people, many students wants to get this very good and good in their notebooks. You people can not get that in this course, right?
Yeah, man.
At least
We are
you have.
missing those days.
All right. So you have all this data now ordered. Okay. So now n is equal to 13 is an odd number. So whenever you are having an odd number, the median position is given by this value n plus 1 by 2. So in this case, what is your n plus 1 by 2?
7.
So what is the category in the 7th position? So you have to look at the position, right? So first, second, third, fourth, fifth,
Good.
and 7.
Madam, one poor is missing, right? We have one very poor and 3 poors.
One very poor.
And 3 poor. So we have put only 2 poors.
Okay, 1, 2, and 3 poor. Yes, correct. Correctly pointed out. Sorry for the mistake. So it's very poor and then poor.
Then
So-
erase that one. Very good.
Sorry, what? What were you saying? Someone was saying something. Some letters got erased. So poor, fair. Yeah. So 1, 2, 3, 4, 5, 6, and 7. I've missed to use the other color. Yeah, anyway.
Ma'am,
So the median value, yes?
ma'am, we will get the same answer even if we arrange this in reverse order of the current one, right?
Yes. Right, because it's in the middle. So either you do it from the left or right, it's going to give you the same answer.
Ma'am,
Right.
I have a doubt.
Yeah.
Like 13 is odd, so we concluded that it is n plus 1 to finding the median. Or is it only applicable for odd or for even also?
Yeah, so we are going to look at the even case. Okay.
I think during even we will get 2 modes.
Yeah. So here, suppose if we are having even number. So for example, here we are having even number of data. So now in the even number of data, so here again, how many very poor are there? Even any very poor? There is no very poor at all, I guess, right? So only poor. How many poor? 1, 2. So we have 2 poor. And then do we have fair? 1, 2, and 3 fair. And then how many good? 1, 2, 3, 4. Good, good, good. And then very good is 1, 2. Very good.
No, ma'am, good are 4.
Good is 4. 1, 2, 3, 4. I missed 1. Okay, so very good and then excellent. Right? Okay. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, everything is there. And now since we are having even numbers, now median position is taken by 2 values. Okay, so both n by 2 and n by 2 plus 1. Okay, so in this case, what is n by 2? 6. And n by 2 plus 1 is 6 plus 1, 7. So both the 6th and 7th position are going to give us the median values. 1, 2, 3, 4, 5, 6, and 7. In this case, luckily, both are good. Okay, so both this good and good are the median position. Okay, so good is in the median position. Sometimes it is also possible that something different like fair and good or good and very good coming together in 6 and 7 is also possible. Okay.
So here 6 and 7 is median.
Yes, in this case, both 6 and 7 are the median values. Okay, so that is what is mentioned here. So if there are even number of observations, choose the category on either side of the middle of the sorted list of the as the median. So if you see, this is kind of the middle position. After 6, this is kind of the midpoint of this data, right? If we are splitting based on the count. So either side of the middle, whatever is there, that is considered as the median category. Okay. Fine. All right. Okay. Now, one last exercise. So, can you all do this exercise now? Find the median and mode.
Yes, ma'am.
The mode is satisfied.
Ma'am, more, what are the topics left to cover up for today's session?
I guess I'll
It is
wait
the
for the others
odd.
also to complete. Maybe I'll ask the answer after a minute. So please wait till the others answer, complete the problem.
Satisfies is the mode.
I is the mode, ma'am.
Okay, so let's see the answers now. So first of all, we need to order, but here luckily it is already in order, right? So there is nothing to
Mode and median are same satisfied.
order. Yeah, so here which one is the mode?
Satisfied.
Satisfied is the
Satisfied.
mode.
Because neutral, how many times is it appearing?
4 times.
Times.
4,
Satisfied, it is appearing
5,
5.
5 times, and very satisfied
2 times.
2 times.
2 times.
Twice.
So this is the mode. And here, how many data are there? 11.
11.
Odd. So if it is odd, the median position is given by
n plus 1 by 2.
11 plus 1 by 2.
6th position.
So it is 6th position,
Hmm.
right? So 1, 2, 3, 4.
Satisfied only.
This is the median. The mode and median are same in this case. Okay. But is it necessary that the mode and median are always the same?
No, ma'am.
No.
No. Okay. So for example, here in this case, what is the mode? We know this is the median. What is the mode in this case? I guess it's very good, right?
1 minute, 2, 3. I think very good.
This looks like
Very
very
good.
good.
Mode
Very
is
good.
given by very good.
Very good.
Okay. So median and mode are different. Okay. So note that median and mode need not be same. Both are some measures of central tendency only, but they need not be same. Okay, fine. Which of the following can be defined for both nominal and ordinal data?
Option C, mode.
So mode. For both nominal and ordinal means it is mode, right? So can we describe median for nominal data?
No.
No.
No, ma'am.
Not for nominal.
Only for ordinal.
Yeah. And this is neither for nominal or ordinal, right? Okay. So here is another question. In order to maximize her profit on sales of mobile phones by buying bulk amount, a seller wishes to analyze the sale numbers of all known brands in the market. Which measure should she use to decide the brands that have been sold in large numbers?
Mode.
Mode, ma'am.
Mode.
Mode. Right. So in which kind of scenario do you think median is going to be applicable?
The data is ordered.
To find which has given the most profit.
The data should be ordinal in that case.
Yeah. So just I'm asking about some the real life inside.
To find the mobile model which has made the maximum profit.
Sorry, someone is asking what maximum profit?
No, I'm saying the median can be used when you want to see which mobile model has made the maximum profit.
Maximum profit, in that case, you want to look at median.
Or the highest number of mobiles sold.
Okay.
But
So,
medium gives you the middle.
oh, you are
value
asking in the
of the
case of
ordinal.
which number is having highest sales, you want to see again mode only, right? So, sorry, I missed your question. What was your question?
No, you are right, madam. I thought if we want to find which has made the maximum profit, which model, then can we use median?
No. So again, you see that mode is going to make sense, right?
But
ma'am,
in one example,
he's asking which one brand phone is sold at maximum profit, not which model has been sold many times. The one model which has maximum profit on it. So how do we find that? He's asking that.
See, here if you are, suppose you are having several different brands, brand 1, brand 2, some 10 brands, let us say, each having some specific frequencies, 56, 72 and whatever, 101, so something like this. So mode is the one which is having the highest frequency, and the brand which is having the highest frequency is the mode. So that is the one we are going to choose, right? Right? Mode is not representing the frequency, it is representing the brand with highest frequency. Right?
Okay, so here question are saying that sold in large number, so that's why it is mode. Is that?
Which measure should she use to decide the brands that have been, so decide the brands. The question is about the brands that have been sold in large numbers.
Yes,
So
understood.
it is more,
So
right?
if you want to talk about the price profit based on the numbers, if you
See, the
have the
profit is
net,
again, which brand is going to make highest profit? That for that you need a different set of data, right? So what is the
yes,
price of each of those brands? And then what is the total profit it is making? So suppose if something is having highest rate, that does not mean that it is making highest profit, right? It also depends on the number of products sold in that specific brand. So overall, we
yeah,
need the complete score of what is the score or what is the sales rate of each of the brand. Only with that we can answer.
we
Again,
have
one
the
thing is
frequency
sales
already,
rate.
right? So if we have the total revenue, we can get the actual revenue per brand.
I'm really sorry, I cannot understand what you are saying. The voice is kind of very much disturbed. I cannot hear you clearly. What
Can
will
you hear
you
me
say?
now?
Yes, can you please try again, maybe slowly and
So
loudly?
we already have the frequency, right? Relative frequency.
Yes.
So if we have the net revenue we made from selling all the band's phone,
Yes,
and
if
by
we have the
multiplying
price
the
of each of
frequency,
the
we can
brand
get,
and the frequency, then we can decide. Yes.
yes.
Yeah. So we need something more to answer the other question which you asked. But again, in that case also, you have to calculate which is the brand with highest sales rate, and based on that highest sales rate means again it is kind of coming as a mode only. Okay, fine. So I was asking about in which scenario maybe median can be coming. So it is, as I told you, it is completely based on position. So some scenario where the position matters. Okay, for example, suppose let us say you are in a theater and let us say you are given the how many number of seats are there in a row. Okay, so usually the middle position has a better view if you want to really watch the movie without much disturbance and have a nice view. So then in that case, you see the number of seats in the row, calculate the median position, right? So wherever the position matters, there the median comes into play.
We can also use in the case of grades obtained by the students. Because it is also ordinal, because if we are considering the frequency count of all the students who got something
Median
like
can be found in that case, but will it make sense? That is something we have to think about, right? See, why do you want to look about the median of a grade? What is it going to give you?
no, ma'am, if we are taking the median score of the marks which were given.
Yeah, you can see sometimes in some universities or colleges, sometimes the scores are given in terms of percentiles, right? Within
Yes,
which
ma'am.
percentile you are falling, yes, their median comes into play, correct? Yeah, good, very good. So now we all have an understanding of what is median, mode, where are they used, right? I hope now we all have a better understanding of these two concepts. Yeah, I have completed the topics I have intended to cover. So going back to the first page, so I was able to summarize all the topics presented here. So are there any doubts in the topics which we have discussed today?
Ma'am, have we covered entire week 2 content, or is there any more to cover?
I have covered entire week 2, at least whatever is required to complete the problems from week 2, I have covered. I cannot say everything like AQPA, no, but whatever is required for the theory part, I have covered, and I try to give as much examples to make sure you understand each concept. Was it all right, the session?
Yes.
Ma'am, I have a
Yes,
doubt.
ma'am.
Yes.
In week 2 practice assignment,
Mm-hmm.
the first question, ma'am, the train question.
Okay, just give me a moment. I'm opening that question. Which question you are talking about? For me, the
Practice
first
assignment
question is about
2.2
two
question number 1.
dice. Two biased dice A and B. That is the first question for me.
2.2.
It's 2.2.
Ma'am, she's saying practice assignment 2.2 question 1.
Yeah, okay. So what is the percentage of berth filled in the train on the given day? So what's your doubt in this?
Ma'am, the whole question. Ma'am, please, can you explain it? I'm finding it difficult to understand.
Okay. Rajdhani trains connect the national capital of India with state capitals. It's better if I can write that complete question and then explain it. So there are like 3 classes and then 10 money birds were filled. What is the percentage of birds filled in the train on the given day? Okay, so let me try to write whatever is given there.
That question also tricked me too when I was solving it. Had to
So
read it 4 times.
sorry, what are you asking?
That question also tricked me too when I was like reading the question. I had to read it 4 or 5 times to get it.
I'm sorry, what are you saying, miss? 1848 and 64. So 1848 and 64. So this is the total capacity, and on a specific day, 10 and half of 2A and 275.
That's the total capacity of each coach, right?
Yes, it's the total capacity of each coach,
And
and
then
there are
there are
multiple coaches
multiple
in the train.
coaches for each class of coach.
Oh, so okay, maximum capacity of, okay, fine. So you have now 18 berth, 48 berth, and 64 berth. But how come the maximum capacity for third A is 64, but then the total 275 were filled?
Yes,
There is
That's
some
what
ambiguity
I'm
in the
saying, that
question, right?
it's the capacity for each berth, each coach, sorry.
Yeah. So in
For
3A, the maximum capacity is 64, right?
yes,
How
ma'am, but there are 9 coaches for 3A, right? So you multiplied
Oh,
64
I
by
did
9.
not. There were 9 coaches for 3. That part I missed. Where is that? Oh, so there is 1A and 5 A's. Okay, fine.
Yeah, that was the trick.
Okay, 5 2A and 9 AC. Okay, this part I missed. 1A and 5 159. So you have, this is into 1 and then into 5 and this is into 9. So can you compute these values and tell me?
48 into 5, 240.
This is 240.
48 into 5.
This is
And it is 576.
576. All right. Okay, so what's the total? 18 plus 240 plus 576.
834.
834.
All right. Now, the filled here, they have mentioned in 2A, half of it is filled. So it should be 120. So now here, it should be now 10 plus 120 plus 275.
405.
405 is filled. So 405 by 834 should give you the answer, right?
Okay, ma'am. Okay, ma'am.
Yeah.
Okay, ma'am, thank you.
Ma'am, I also have a doubt in practice assignment 2.2. Question number 4.
Question number
4.
4. Okay. A contract for sports jerseys. Okay, so since we are almost at the end of the session, shall I do one thing? So we are having this solve with a session on Sunday, if I'm correct. So I have mainly considered problems from 2.1 in today's session. While doing solve with us, shall I just take some problems from this 2.2 and we will discuss the problems from 2.2 on Sunday? Maybe
Okay.
not just 2.2, many problems from 2.2.
Ma'am, but today in the morning session, which was taken by TS, it was only discussed. Already discussed.
They are that then they have already discussed means you have already the solutions. But if there are doubts, then maybe we can discuss again in the next session because we are almost at the end of the session now. So whatever doubts we again have, we can again maybe discuss in Sunday session or Tuesday session. Will that be fine? Yeah.
Okay, ma'am.
Yes, ma'am.
Thank you.
Okay. I hope the session was useful for everyone. Thank you, everyone. See you again.
Yeah,
on
ma'am.
Sunday. Yes.
Thank you, ma'am.
Thank
Thank
you,
you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.